Welcome back, everybody. In this video we're going to explore some different examples of exponential functions and different aspects of them, exponential growth and decline. So look at this first one. We just want to graph the exponential function -3 to the power of x minus 2. The fact that we have a variable here in the exponent says it's an exponential function. -3x minus 2. I think I have that here on Desmos, desmos.com, calculator. Here it is on the first one. Let's have a look at that. We'll zoom in. So it looks like it's exponential decay. It is definitely decreasing. Let's click the home button here. There we go. And notice it's crossing down here at 0, -3. It comes to a horizontal line. There's almost a horizontal asymptote, we call it, at -2. The line gets really close to it but never touches it. And then after that it just drops down and gets smaller and smaller. So that's what that exponential function looks like. Let's look at another one where we're asked to graph. This time 0.25 to the power of x plus 5. 0.25 to the power of x plus 5. Have it right here. And let's have a look at this. Okay. Interesting, it's coming from the left, comes down, crosses right here at 0.6, and then notice the y values go on. Notice they get really close to 5. It looks like it's right on 5, but technically it's never touching. We got a horizontal asymptote, we call it, at y equals 5. Okay, let's look at another one here. Alright, it says which points are on the graph of g of x equals 1/4 to the power of x. Well, we can go through and test each one and just see if it's a true statement. So the y value is g of x, and then 1/4 to the power of 0. If you raise something to the power of 0, no, that equals 1. So this is like saying 1/4 is equal to 1, and that's not true. A is definitely not it. Let's try the next one. 4, and for the y value, 1/4 raised to the power of 1. Nope, 1/4 does not equal 4. Alright, let's try this one. 4 here. 1/4 to the power of -1. Yeah, -1 exponent kind of flips the fraction around. So really another way of saying this is 4 equals 4. That definitely works. And then, so C works. Let's see if D works. 3 equals 1/64. So 1/64 is equivalent. Is it equivalent to 1/4 to the third power? 1/4 to the third power, 1/4 times 1/4 times 1/4 does equal 1/64. So that works. -1/4, 3 and 1/64. Let's verify that with Desmos. Here's our function here. And what were we looking for? -1. -1, 4, there we go. That was that third choice, letter C. Almost had it there. There it is. And then 3, there we go. Close. It's not exact there. Oh, there it is right there. 0.016 is the same thing as 1/64. Alright. Next one. Looks like we have a story problem here. It says Tom buys a ton of straw every year. First time he bought a straw in year 0, it cost $150. He noticed the price is getting less expensive at a rate of 1.5% per year. It's decreasing by that amount. Create an equation and graph this situation that describe the behavior of the graph. Alright, so this is just exponential growth. Your ending amount equals the starting amount. And we're exponential decay, actually, 1 minus the rate, raised to the t or the x power. I'll call it x. So in this problem here, 150, 1 minus 0.015 raised to the x power. So there we go. We want this. We graph it and kind of see what's going on here. Let's go over to Desmos. Here we are. 150 minus 1 minus 150 times 1 minus 0.015 to the x power graph. And then It's the home. We're going to have to zoom out to see this. Yeah, and it's pretty big since there we go. We're at 150, and then here's the price. It's just going down, 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 down. And apparently we'll keep going. I don't think it will ever equal 0, but it apparently gets exponentially close to 0. All right. There we go. Now the next one. Describe the end behavior of f of x equals 3 times 1.85 to the x power plus 3. The end behavior. So when you talk about end behavior, you're basically going to the left forever, and you're going to the right forever. Going to the left forever, going to the right. Let's look at Desmos. Here it is. F of x equals 3 times 1.85 to the x power plus 3. All right, as we go to the left forever, see, it just seems to level off, doesn't it? Levels off at y equals 3. All right, looks like we have an end behavior asymptote. But then if we go to the right forever, notice it just keeps going up and up and up and up and up. There we go. All right, so here's how we're going to describe this. We'll describe it in terms of x and the x coordinates are. Let's see if I can copy and paste this statement. There we go. As x decreases without bound, that means go to the left forever. The graph approaches y equals 3. It gets close to that horizontal asymptote. As x increases without bound, the graph of f of x increases without bound. It means as we go to the right, it's just going up and up forever. And we saw that here. We're approaching the line y equals 3. But on going to the right, it just goes up and up and up forever. All right. Next one. What is the asymptote of g of x equals 0.75 to the x power plus 2? Back to Desmos. G of x equals 0.75. X, all right. And we can zoom out a little bit. Looks like it's leveling off. Look at the y values. Seems to be y equals 2. Alright, and then the last few here, we already have the graphs given us. The graph of g of x is a transformation of the graph of f of x equals 2 to the x power. What is the equation? Well, it may help to look at f of x equals 2 to the x. Let's go back to Desmos. Put that equation in. F of x equals, what was it, 2 to the power of x. Alright, and let's just look at the basic function. So it starts out here, the original function 0, 1, and now it's right here. It looks like it went down 2 spaces. It actually looks like it went down 3 spaces. Alright, 1, 2, 3. It was the original, goes through here. Alright, so what's the equation g of x? I think it would be this. G of x is equal to 2 to the power of x, and then minus 3. We can verify that on Desmos. Two to the power of x, and then minus 3. Yep, there it is. See where it crossed down here? There you go. You can always verify these on Desmos. Alright, so look at another one here. Graphs are given. The graph shows f of x and its transformation. Write the equation of g of x. Alright, so it looks like we have f of x equals 1/2 to the x power, and g of x is right up here. So how did this transform? First of all, let's look at the vertical translation. The original function here, looks like it has a horizontal asymptote at 0. The second one, if you look here, it is leveling out at 5. So g of x will be the original function, (1/2) to the power of x, and we definitely went up 5. We have a plus 5 added. But it also looks like a horizontal shift happened. Alright, and if we pick a point on the original graph and then count over, it almost looks like, if you count the spaces, each notch is 5. It almost went 2 full spaces, almost, maybe just a little bit less. So it may have shifted to the right 9, I would say. And if we shift to the right, we have to adjust inside the function, so to speak, where the variable is. The variable was up here as an exponent, so we go x minus 9 up there, and then plus 5. And we can test it out on Desmos for sure. Here's the original function, 1/2 to the power of x minus 9 plus 5. Yeah, notice how we level off at 5 here. Leveling off at 5. Look at those y values. And then let's pick a point here, right here, and count. All right, a little bit further. 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe it might even be 10. 9 or 10. It's close to it. It's close to it. All right, so that takes care of that one. Let's look at one more here. What is the equation of the function shown in the graph given the equation of the parent function 3.5x? The original function is 3.5x to the power of x. 3.5 to the power of x. And 3.5 to the power of x by itself would have a horizontal asymptote at y equals 0. But then the new function, g of x they call it, notice it was shifted down to, notice it's an asymptote, 3.5 raised to the power of x minus 2. And we can verify this on Desmos. Check these out real quick. F of x equals 3.5 raised to the power of x. There's that. And then g of x, the new one, 3.5 to the power of x, and then minus 2. Notice it shifted down 2 spaces. And there we go. All right, thank you for watching. Hopefully this helped with your understanding of the graphs and behavior of exponential functions. Thank you for watching.